Baalbek, Lebanon. And what the algorithms detected under those ancient stones finally cracked a mystery that defeated the greatest minds in archaeology for over a century. The laser pulses penetrated deep into limestone bedrock and returned three-dimensional maps of something the original builders deliberately concealed underground. Something massive. Something engineered with a precision that should not exist at that point in human history. When the research team first rendered the point cloud data on their monitors, the room fell completely silent. Hidden construction phases, buried structural layers, stone fitting tolerances measured in fractions of a millimeter across joints between blocks, weighing 800 tons each. Their scanning equipment was accurate to 1 centimeter. The ancient builders were accurate to less than that. Everything we thought we understood about Baalbek was wrong. This is what the LiDAR finally revealed, and why the answer is more unsettling than the mystery itself. Baalbek sits in Lebanon's fertile Bekaa Valley, about 86 kilometers northeast of Beirut, perched on a hilltop 1,150 meters above sea level. Today, it is a UNESCO World Heritage Site inscribed in 1984. Tourists arrive by the busload. They snap photographs of 6 towering Roman columns, the last survivors of what was once the largest temple to Jupiter in the entire Roman Empire. Those columns stand nearly 20 meters tall, the tallest in the classical world, with a diameter of 2.5 meters each. Above them once rested a pediment whose apex reached an estimated 44 meters above the temple floor. Visitors admire the remarkably preserved Temple of Bacchus next door, 66 meters long, 35 meters wide, 31 meters tall, one of the finest examples of Roman architecture anywhere on Earth. They walk through its massive stone doorway, marvel at the intricate carvings, and then they leave. Most of them are completely unaware of what they were actually standing on, because long before the Romans built their temples here, long before the Greeks renamed this place Heliopolis, the city of the sun, long before the Phoenicians consecrated this ground to the god Baal, something extraordinary was constructed on this hilltop. Something so impossibly large that when Mark Twain visited in 1867, he wrote in The Innocents Abroad that a race of gods or of giants must have inhabited this place. He said he had seen the hull of a steamboat that was smaller than one of those stones. All these great walls, he wrote, are as exact and shapely as the flimsy things we build of bricks in these days. Men like the men of our day could hardly rear such temples as these. He was staring at the Trilithon. 3 horizontal stone blocks form part of the temple platform's western wall. Each one stretches 19 meters long, stands 4.2 meters high, and measures 3.6 meters thick. Each one weighs approximately 800 tons. That is the combined weight of 2 fully loaded Boeing 747 aircraft compressed into a single block of cut limestone. And these stones do not sit at ground level. They are elevated 7 meters above the earth, resting on a supporting course of stones that themselves weigh 350 tons each. The stones above and below are fitted together with such precision that even today, after 2,000 years of earthquakes, invasions, and erosion, you cannot slide a sheet of paper between the joints. Imagine lifting 2 commercial airplanes to the height of a 2-story building and positioning them to within a fraction of a millimeter. Now do it 3 times in a row with no electricity, no steel cables, no diesel engines, no computer-guided cranes. That is the Trilithon. But the Trilithon is not even the largest stone at Baalbek. Not even close. And what lies beneath these megaliths would turn out to be far more shocking than what stands above them. Here is where the story truly begins. In the summer of 2014, archaeologists from the German Archaeological Institute were conducting excavations in the ancient quarry located about 900 meters from the temple complex. The team was led by Dr. Margaret van Es, scientific director of the Institute's Orient Department, working alongside Professor Janine Abdul Masih of the Lebanese University. They had been studying the famous Stone of the Pregnant Woman, a monolith weighing approximately 1,000 tons that has sat in that quarry for over 2,000 years, partially raised at an imposing angle. Its surface smooth tricked the people of Baalbek into believing she knew how to move the stone, promising to share the secret if they fed her until she gave birth. Another version claims pregnant jinn were assigned the impossible task and abandoned it. In the 1990s, a second monolith called the Stone of the South was rediscovered in the same quarry, weighing 1,242 tons. These two stones alone represented the largest quarried objects known to archaeology. The team was documenting tool marks and quarrying techniques, searching for datable pottery fragments in surrounding waste dumps. Standard fieldwork designed to confirm what textbooks already stated. Instead, they uncovered something the textbooks had completely missed. Buried directly beneath the stone of the pregnant woman, concealed under meters of accumulated sediment, lay a third monolith. Larger, much larger, it measured 19.6 meters long, 6 meters wide, and at least 5.5 meters thick. The German Archaeological Institute confirmed in their official statement that the level of smoothness indicated the block was meant to be transported and used without being cut further. This was a finished engineering component shaped to final specifications. When they calculated its weight, Dr. Van S. immediately requested independent verification. The number came back identical every time. 1,650 tons, the largest precisely carved stone block ever discovered in human history. To give you a sense of that weight, the Statue of Liberty, including the pedestal, weighs approximately 27,000 tons. This single block of limestone represents 6% of Lady Liberty's entire weight. One stone, carved from bedrock, by hand. And here's a detail that does not get enough attention. When the German team examined the tool marks on these quarry stones, they found something remarkable. The forgotten stone surfaces were not roughly hacked out of the bedrock. They were worked to smooth, flat planes with extraordinary consistency. The cutting precision visible on the narrow side that had already been fully dressed matched the quality of finished architectural stonework. These were not trial cuts or rough extraction marks. They represent the same level of craftsmanship you would expect on the visible face of a completed temple wall. Whoever carved this stone intended it to be seen. They intended it to fit against other stones with the same hair-thin precision found in the trilithon joints above. The quarry itself tells a story that goes far beyond simple stone extraction. The positioning of the three monoliths, stacked and adjacent, reveals a systematic mining operation of industrial scale. The builders were not opportunistically pulling random blocks from convenient outcrops. They had identified specific beds of high-quality limestone within the geological formation and were extracting from them in a deliberate sequence, planning multiple simultaneous extractions of objects that each weighed more than 1,000 tons. This requires geological knowledge. It requires structural engineering knowledge, because removing a block of that size from bedrock without causing the surrounding stone to fracture demands understanding of stress distribution and load transfer. It requires project management on a scale that challenges modern industrial planning. Think about what the quarry arrangement implies. To extract the larger stone, the builders would first need to remove the 1,000-ton block sitting directly on top of it. They were quarrying on a scale that assumed the routine movement of objects heavier than anything human civilization would move again until the 20th century. The excavation had to be suspended because the trench became dangerously deep. They had not yet reached the bottom of this buried giant. To this day, no one knows its complete dimensions. There could be more stone beneath what they have already measured. Here is where it gets genuinely disturbing. Modern engineers have examined the logistics required to move these stones, and the mathematics do not work with any known ancient technology. In 1977, the French engineer Jean-Pierre Adam conducted the most rigorous study ever published on the trilithon transport problem. Using detailed mechanical calculations, he determined that 512 workers operating wooden rollers, capstans, and pulley blocks could potentially move a 557-ton block. That is roughly half the weight of a single trilithon stone. He could not solve the full 800-ton problem with available Roman technology, and he acknowledged as much in his paper. Other researchers estimated 40,000 men working in flawless coordination could lift stones weighing up to approximately 60 tons. The architrave and frieze blocks of the Temple of Jupiter itself weigh up to 60 tons each, which already required exceptional effort to raise over 19 meters into the air. But the platform stones are more than 13 times heavier than the heaviest blocks Roman cranes were designed to handle. Even if you combine multiple cranes, the coordination challenges of simultaneously lifting and maneuvering 800 tons of limestone are practically insurmountable without modern hydraulic systems. The largest mobile crane operating today, the Liebherr LTM 11209.1, has a maximum capacity of approximately 1,200 tons at extremely close range. Specialized heavy lift companies like Mammoth can handle up to 2,000 tons using purpose-built gantry systems that take weeks to assemble, require kilometers of reinforced ground preparation, and cost millions of dollars to deploy. The Forgotten Stone, at 1,650 tons, falls within this extreme operational range. It could be moved today, but just barely, and only with the most advanced equipment on the planet. For historical comparison, the Russian Thunderstone, moved for Catherine the Great in 1768 to serve as the pedestal for the bronze horseman statue in St. Petersburg, weighed approximately 1,200 tons. Transporting it 6 kilometers overland through marshland and then across the Neva River on a specially designed barge was considered one of the greatest engineering achievements of the entire 18th century. Hundreds of workers labored for months. The project consumed extraordinary national resources and was celebrated as proof of Russian imperial ambition. The individual trilithon stones at Baalbek are 2/3 of that weight, and the ancient builders moved 3 of them, elevated them 20 feet, and positioned them with millimeter precision as a routine component of a much larger construction program. Before NASA moved the Saturn V rocket to its launch pad in 1967 on a purpose-built crawler, no entity in modern history had ever transported anything approaching these masses over any significant distance. The ancient builders did it with rope, timber, and human coordination on a scale we struggle to replicate today. But the real breakthrough came when advanced scanning technology arrived at Baalbek. A UNESCO-funded project brought together a multidisciplinary team from Lebanon, Taiwan, and Belgium to conduct the first comprehensive three-dimensional laser survey of the entire site. Using terrestrial LiDAR scanners, including the Leica Scan Station P30, the team captured millions of data points per second with sub-centimeter accuracy. They generated exhaustive point clouds of every surface, every joint, every structural element across the temple complex. The technology fires rapid laser pulses at surfaces and measures the precise round-trip time of each reflection, building extraordinarily detailed three-dimensional models without touching or damaging any of the protected ancient stonework. Simultaneously, aerial photogrammetry using high-resolution cameras captured panoramic imagery of the Temple of Bacchus and its surroundings. The combination of laser scanning and photogrammetric data allowed researchers to create what they called a digital twin of the ancient site, a perfect three-dimensional replica accurate to the millimeter. When AI-assisted processing algorithms analyzed these massive datasets, patterns emerged that no human observer could have detected through centuries of visual inspection. The scans revealed previously invisible construction phases buried within the platform walls, distinct masonry styles layered on top of each other, each representing a different era of building, different techniques, different tools. The point cloud data stripped away the visual noise of weathering, lichen, soil accumulation, and restoration patches to expose the raw geometry of how these stones were actually cut and assembled. Here is a detail that stunned the research team. The AI pattern recognition algorithms, trained to detect geometric anomalies in the scan data, identified systematic differences in stone cutting angles between the lower and upper courses of the platform wall. The lower megaliths were cut with techniques that left characteristic tool signatures unlike anything found in Roman stonework elsewhere in the empire. The upper Roman additions, by contrast, showed standard imperial-era chisel patterns well documented at sites across the Mediterranean. Two completely different construction traditions, separated by centuries or millennia, stacked one on top of the other. The platform was not built in one campaign. It was built in stages by builders who did not even use the same tools. The three-dimensional models also revealed